Hello everyone, welcome to Pepcoding. So in this video we are going to discuss a question which is count good nodes in binary tree. So basically we will be given a binary tree and we have to count the number of good nodes present in that binary tree. So here we will focus on good nodes. So what are good nodes? So a node x in the tree is named good if in the path from root to x there are no nodes with a greater value greater than x. Suppose this is a value 1. It is that is node x, and this node x is named as good if in the path from root to x, means from path from root is 3, root to x is 1, so path from root to x will contain 3, 4 and 1, which is x, and this is root. There are no nodes with a value greater than x, so in this path there should be no value which is greater than x. So in this particular path 3 and 4 are the values greater than x, means greater than 1. So this one cannot be a good node, not a good node. Another case, if we take a x value as 5, so we will check whether 5 is a good node or not. So we will take the path from root to x, from root 3 to 5. So this will contain 3, 4, 5. This is x and this is root. So there should be no node greater than x. So is there any node greater than x? No, there is no node greater than x in this path. So 5 is a good node. Okay. Same we'll check for 4. In the path of 4, 3 and 4. Is there any node greater than 4? No, 3 is smaller than 4. So it will be a good node. Now we'll check for 3. Is 3 is a good node? Yes, 3 will be a good node because in the path from root to 3, there is only a single node, that is root itself. Because 3 is not having any root. 3 is the root itself. So 3 will be a good node. Okay. And same is the case with this 3. If we'll see this 3, we'll check whether this 3 is a good node or not. So 3, in the path of this 3, there is 3, 1 and 3. 3, 1 and 3. So there is no node greater than 3. This root is not greater than 3. It is equal to 3, but it is not greater than 3. So this 3 will be a good node. If there had been 4, then this node can't be a good node because in its path from root to x, 4 is greater than this node. So this node can't be a good node. But since here is 3 and it is equal to 3, this node is not greater than 3. So this 3 will be a good node. I hope you have understood this problem. Now we will discuss its solution. Okay. So for this particular node, 3 is a good node, 1 is not a good node because from its path from root to x, this is greater than 1. So 1 is not a good node. 3 is a good node because in its path, there is no node greater than 3. Where I am taking the name of path, then path means root to node path, means root to that x path. Okay. If we'll take this 4, this will be a good node because in its path there is no node greater than 4. 1 can't be a good node because in its path 4 and 3 both are greater than 1. And in 5, in this node, this will be a good node because 3 and 4 are smaller than 5. These are not greater than 5. Okay, so in this particular binary tree, number of good nodes are 1, 2, 3 and 4. So talking about its solution, what we'll do, we'll do some work in pre-order. We'll traverse, and what we'll do, we'll be taking a maximum value. We'll not be we'll be taking maximum. We will be not comparing the node with all the nodes. Means if we are checking for 5, we'll not be comparing 5 with 3, 4. Means all, see, this time the tree is small. If we'll take a large tree, that is 7, 3, 6, 4, 5, 9, 3, 14, then what we'll be doing, if we'll checking for 14, if we'll be checking for 14, then we won't be comparing this 14 with all the nodes in its path. Means with 7, 4, 5, 9. Rather, what we'll be doing, we'll be taking maximum of all these nodes, and we'll be comparing that maximum with 14 and checking whether the maximum from this is less than or equal to root. Means this value, if it is if maximum of all these nodes, maximum of all these path nodes is less than or equal to root, then that node will be our good node. So we have discussed the approach. Now we will code for our approach. So this is our function of good nodes, and from this function we'll call our function count good nodes. We'll pass this root value and our maximum value. So maximum value will be, initial maximum value will pass as minimum. So whatever this function will return, we'll return this. This will return an integer value, that is count of good nodes. So we'll return this value from here. So our next step will be creating our function good nodes and a maximum value. So our base condition will be if root equals to null ptr, then return 0, and we'll check the condition if value of root is greater than or equal to root maximum value. Then it means we have obtained our answer. We have counted one good node. So we will make our answer as 1, and initially it will be 0. If we didn't hit this condition, it means we haven't got any good node. So answer will remain 0. And if our value, root value, is greater than or equal to our maximum value, it means we have obtained a good node. So now from here, we'll update our maximum value. So these things we have done in pre-order. Now we will call for our left. So left side will give the count of good nodes. updated maximum value, and same thing we'll do for the right call. This was left and this one is right. And at last our answer will become previous answer plus left value plus right value, and we'll return our answer. So let us do the dry run. Okay, I hope it is visible. So this is first set of statements, second condition, third updation, fourth left call, fifth right call, update answer, return answer. So initially root value will be 3 and maximum is minus infinity, that is minimum value. Max value is this. So we'll check the first condition. First condition will be false. Then we'll check second condition. If maximum value, so maximum value, this is root and this is maximum value. If maximum value is less than equals to root value, then our answer is 1. So our answer will become 1 over here. Now we'll check third condition and we'll update our maximum value. So maximum value will become, so maximum out of this is 3, so maximum will become 3. So now from here we'll jump into this fourth statement. So we'll call to its left. Again it will give 1 comma maximum value was 3, 1 comma 3. So here first condition will get checked, which will be false. Then second will get checked, max value, that is 3 is less than equals to 1. So condition is false. So answer will remain 0. It will not get updated by 1. So answer will remain 0. Means here this is not a good node. Now we'll check third condition. So it is maximum value. So max value was 3 and root value is 1. So out of these two, max is 3. So max will remain 3. Now fourth statement, we'll call to its left. Here 3 and max value 3 is passed. So we'll check first condition, which will be false. Second condition, which will become true. How? Maximum value is 3 and root value of root is also 3. So 3 less than equals to 3. So this condition will become true. So answer will become 1 and maximum will become max value. Previously max value was 3, root value is also 3. So maximum out of these two is 3. So max will become 3. Now call to its left. Calling left, it will encounter a null PTR. So it will return 0. This 0 will get attached to left. And from here right call will be made and it will encounter null pointer. It will return 0. 0 will be obtained by right. So till now we have executed till fifth statement. Now it's turn for 6. So answer will get updated by previous answer, that is 1 plus left plus right. So it will be 1 plus 0 plus 0. So 1 and return the answer. This answer is returned and is obtained by left. Now fifth statement, call to right. Right will encounter a null PTR. It will return 0. 0 will get attached to right. So now sixth statement, answer will get updated to previous answer plus left plus right. So this will be, previous answer was 0. This one is left and this is, so here it was 0. See, here it was 0. Why? When we have encountered this to this left call, then this condition was false. See, we have missed a point. When we have made call to its left, then max value was 3
and root value was 1. So 3 is less than equals to 1, which condition was false. So answer was 0 over here. Okay, so answer, because this condition was false, 3 is not less than equals to 1. So answer will remain 0. It will not updated by 1. So here answer was 0, and while returning, answer is answer plus left plus right. So it will become previous answer plus left plus right. So it will be 1. Now it will return answer, and this answer will obtain by left. So answer is returned obtained by left. Now call to right. Calling to right, it will get 4 and maximum value is 3. So it will check first condition, then second condition, max value that is 3 is less than equals to 4. So this is true. So this condition is true, that is why answer will become 1. So answer will become 1. Now max value will get updated by previous max, that is 3 comma 4. So it will be 4. So max is 4. Now calling to left. Calling to left, it will get 1 comma max, that is 4. Now checking the first condition, will be false. Checking the second condition, so it will be max value is 4 less than equals to 1 root value of root. So this condition is false, so answer will remain 0. Okay, because this condition is false. Now third statement, max value will get updated by previous max comma value of root. Previous max was 4 comma 1, so it will be 4. Now calling to left, it will return 0, will get attached to left. Calling to right, it will get null, so return 0, it will get attached to right. Now we are returning from here. See, after left and right call, answer will get updated. So answer will become previous answer plus left plus right, so that is 0. So it will return 0, and this 0 will get updated to get attached to left of it. Now after making left call, fifth statement, it will call to right. Calling to right, it will pass 5 comma maximum value, that was maximum value was 4 over here, so it will get 4. Now checking the first statement, so it will get false. Now second statement, so we will check second statement, maximum value 5, sorry, maximum value is 4 is less than equals to 5 value of root. So we'll compare, this condition will become true, so answer will become 1. Now third statement, maximum will get updated by previous max value comma root value, so it will be 5. So maximum is 5. Calling to left, it will return 0, get attached to left. Calling to right, it will get 0, return 0 will get attached to right. Now we'll update our answer by previous answer plus left plus right, so it will be 1. So now we'll return this one, and this one will get attached to right of it. Now after executing fifth statement, now sixth statement, answer will get updated by previous answer plus left plus right, so it will be 2. So now return this answer, this returned answer will get attached to right. Now we will execute this sixth statement. So this sixth statement will update our answer by previous answer. Previous answer was 1 plus left plus right, so it will be 1 plus 1 plus 2. So it will be 4. So our ultimate answer has received 4 value. Now we'll return this answer, and this answer will be our final answer. So in this particular binary tree, count of good nodes is 4. Okay. So now let us run our code. So still work is going on backend side, so there are no test cases. So if we'll run our code, it will show some errors. So it will be left of root and right of root. So there is segmentation fault because test cases are not present. So what we'll do right now, we'll give some custom input. So for the tree for which we have done the dry run, we'll give input for that tree and we'll check whether this is giving correct output or not. So we have given the custom input. So output is 4. So we have received the correct output. So this is the final code and this is correct. So by the time you will reach at this question, the test cases will be updated. So you will be able to submit the code. So for now, that's the end of our video. I hope you have understood the question and the solution. So thank you for watching. We'll be meeting in another video with another question.